Let's take some time to talk about objects, binding, and the assignment operator in Python. And I'd like to first make a couple notes for people who have coded in another programming language. If you've never coded in another programming language, you can ignore this. But in Python, everything is an object. That includes all the fundamental data types, classes, functions, built-ins, etc. And this is good news because it makes Python more flexible. The other thing to note that comes as a result of this is that everything is passed by reference. Again, if this doesn't make sense to you, that's okay. You really don't need to understand this distinction until you do start programming in another programming language. But let's learn about objects, binding, and the assignment operator by example. For today, we're only going to talk about string objects. And we'll learn about numeric types soon. We've already used string literals inside the print function. A string literal is just some collection of characters enclosed in double quotes, or they could even be enclosed in single quotes like this. The reason we have the choice is that we might actually want to include some quotes inside our string literal. So if we wanted double quotes inside the string literal, we would use single quotes outside. So if we want to name our string literal, running this code, notice that the single quotes do not show up when we print the literal, but the double quotes inside do. Again, if we really wanted Sam to be in single quotes, then we put the double quotes outside. It could happen, of course, that you want single quotes and double quotes inside. In that case, you need to use what's called an escape sequence. The escape sequence for double quotes is the backslash and then the double quote. The backslash alerts the interpreter that the next character is not intended to be interpreted as a double quote, which would therefore close the string, but is actually something that you want printed out. This is a pretty limited use of the print function because when we provide a string literal inside the print function, we're saying that we're always going to print the same thing. What we often want to do is use a variable name inside the print function. To do that, we'll start by using something called the assignment operator. We have a string literal that we want to store in memory. Remember, I said that everything in Python is an object, so this string literal will be stored in memory as an object. We will create a name for that object and use the assignment operator, which is a single equal sign, to bind this variable name to this object. So again, we're creating the string object in memory and then creating a name that refers to that string object. We can then use the variable name to retrieve the object and print it out. I use the formal name of binding, which is to create a map between a variable name and an object in memory. But most of the time we'll speak more loosely. We'll say we're putting this string into this variable or assigning the string to the variable. If we create another string and then bind the same variable name to that string, then this string, my name is Fred, is stored as an object in memory. Then the variable my name, which previously pointed to the memory location containing this string, is changed so that it now points to the memory location containing this string. This previous string object is still in memory, but nothing is pointing to it. So the Python garbage collector will quickly delete that object from memory. If we print my name again, then we see that the variable my name previously pointed to the first string and now points to the second string. This process of binding is important to understand. If we create a number, let's say 4, in memory, and then we bind it to a variable name like one number, we need to understand the difference. 4 is an object stored in memory. One number is a name that refers to that place in memory. If I create another number and also point it to 4, Python is smart enough to know that we already have a number 4 stored in memory. So instead of creating another object 4, it's going to point both of these names to the same object. If you want to get super geeky with this, we can actually find out where each of these names is pointing. We'll print the ID of one number and the ID of another number. And we find that they point to the same object. If we change another number to 5, we find they point to different objects. In fact, for commonly used things like low values of integers, Python creates a bunch of them in memory from the start, assuming that you might use them. This can speed up your code, and the fact that Python won't duplicate the objects if we use 4 for each of these names means that Python is also saving space in memory. Going back to strings, a string is stored as a sequence of characters. We can print out the whole string, and we can also print out individual characters. The first character has an index of 0, the second character has an index of 1. In computer programming, we always refer to the first item of any sequence as the 0 item. So if we want to print out the Q, then this is 0, 1, 2, the space is the third item, and the Q is the fourth. In brackets, I would write the number 4 to access the fourth item of the string, which is a Q. One important thing to note is that I can change the object that first string points to but I can't change an individual character within first string. That's because a string object is immutable. Once we create the object, we're not allowed to change it. All we can do is point the name at a different object. We'll talk more about mutable and immutable objects later in the course. We can do things like combine strings together, though. We have two strings. First string is the quick brown fox, and let's add a space here. And second string is going to be jumped over the lazy dog. I can concatenate those two strings into a complete string. And the concatenation operator is just the plus symbol. Now if we print out the complete string, we have the two strings combined. Internally, we've actually created three objects. The first object in memory is the quick brown fox. The second jumped over the lazy dog. And when we use the concatenation operator, Python actually is creating a third object by combining these two strings and storing the result in memory again, and binding the name complete string to that object. So again, the important takeaways are everything in Python is an object, and every variable name we use in Python points to some object. The assignment operator is used to bind variable names to objects, and binding is a formal term that we won't use very often. More often we'll say we're putting a string into a variable name or assigning a string to a variable name. But at times it's important to remember what's going on behind the scenes.